I wanted to fly through, but go ahead and go through again the information on graphing that we covered last time.
All right.
So we know that sine, we defined sine to be the y-coordinate of every point around the unit circle. We're looking at these y-coordinates. And because I can start at the point 1, 0, go all the way around, and I begin to repeat, we know that sine has to be periodic. It repeats every 2 pi units because the circumference of the circle is 2 pi. And we can write that as sine theta equals sine of 2 pi of theta plus 2 pi. Which is what we have here in the box. Also, the largest that sine ever is 1. The smallest that it ever is -1. So that means that the range of sine is -1 to 1. However, the thing we're plugging in, which is known as the argument, this theta that we're plugging in is the argument. The argument is the angle. Well, the angle can be anything from 0 to 2 pi, but we can keep going, can't we? We can go to 4 pi, we can go to 10 pi, we can go as high as we want. And if we go backward, we can go as far backward as we want. So that means that the domain, the things we're plugging in, are all the real numbers. So the angle can be any real number. The y value, the largest it can be is 1, and the smallest it can be is -1. The sine function is periodic because it's defined on this unit circle. And if we look at, say, let's just look at an example. Here's the angle pi over 3, and we see that the sine of pi over 3 is square root of 3 over 2. And now let's look at negative pi over 3, which isn't a negative measure, it's a negative direction. So at negative pi over 3, we see that the sine is negative square root of 3 over 2. And that's why we say that sine is odd. Because when you plug in a negative, you get the negative. Let's go ahead and look at the same information for cosine. Let's look at pi over 3. Cosine goes with x, so the cosine of pi over 3 is 1/2. And let's look at negative pi over 3. Here it is. And it is also 1/2. And let's check just to make sure we're not just, picking something nice. Let's go over here to 2 pi over 3. No, I'm sorry, 3 pi over 4. We can see that the cosine is negative square root of 2 over 2. And the angle that mirrors this is 5 pi over 4. We're just mirroring with respect to the x-axis. And we do get the exact same x coordinate. So when we mirror with respect to the x-axis, the cosine value stays the same. And that's what it means to be even. Just like with sine, though, cosine, the largest it can be is 1 and the smallest is -1. And it is also periodic with a period of 2 pi. Last time we talked about some nice values for sine. We used pi over 6, pi over 2. We started with 0, pi over 6, pi over 2, pi over 6, pi. And we just did the over 6s and the 2 pi's. And then we filled in with square root of 3 over 2, which is approximately 0.9. And we didn't do this one, but 1 over square root of 2, which in polite society is square root of 2 over 2. That's approximately 0.7. And if we use all of that data, we get this nice shape for the sine function. We can let the argument, the thing we're plugging in, we can call it theta, we can call it x, and we're going to go back and forth. So in fact, these should be thetas, because I went back to theta here. Okay, so we talked last time, the places where the sine function crosses the the x-axis, the x-intercept, are at 0, pi, 2 pi, 4 pi, 5 pi, every single multiple of pi. So if n is an integer, if n is any integer, remember that epsilon means n, z with a double bar means integer, then every single time we have a multiple of pi, the sine function will be 0. We can also see that we have our maxes. Let's see, at pi over 2, we're at a max. 3 pi over 2 min. 5 pi, so we've got pi over 2. 5 pi over 2 will still be a max. 7 pi over 2 is back down here. 3 pi over 2. So all of the odd multiples of pi over 2 are either extremes, are either maxes or mins, but we can describe the numbers 1, 5, 9, etc., as an odd number of the form 4n plus 1, where n is an integer. And we can describe odd numbers 3, 7, 13, etc., as 4n plus 3, with n as an integer. And let's just see, again, very quickly, let's see how we can do that. So how can I know for sure? Actually, let's just pick an odd number. Somebody throw an odd number to me.
5.
Okay. I want to see if 5 is an odd number of the form 4n plus 3. So what I want to do is make an equation and set 5 equal to 4n plus 3. And I want to find n. If n is an integer, then yes, 5 is of the form 4n plus 3. If n comes out not to be an integer, then 5 must be 4n plus 1. So how can I find n?
You would start by subtracting 3 from both sides.
Beautiful. So we get that 2 is equal to 4n.
Then you can divide 4 by both sides.
Beautiful. And we get that n is 1/2. Is 5 an odd number of the form 4n plus 3?
If it's supposed to be an integer, no.
That's right. It has to be an integer when you solve it like this. Well, let's just see for sure that 5 really is an odd number of the form 4n plus 1. So since you subtracted 3 up above, let's subtract 1. We get 4 is equal to 4n, and
Divide by 4 on both sides.
beautiful. And do you see we do get an integer? Think of a really big odd number.
203.
Okay, let's look at 203. And I'm going to guess incorrectly that it is of the form 4n plus 1. How can I show that 203 is or isn't of the form 4n plus 1?
Subtract 1 from both sides.
All right.
And then divide both sides by 4.
And we get n is equal to, let's see, 4 goes into 20. Well, let's just reduce. We get 101 over 2. And since that isn't an integer, then we're pretty sure that 203 is of the form 4n plus 3. And you can see pretty quickly that this has to be the case because 200 is divisible by 4. Every single odd number is
It'd be 50,
one or
not
the other.
25. Sorry.
Say it again.
It would be 50, not 25.
Thank you, thank you, thank you. Yes, thank you. So every single odd number is either 4n plus 1 or 4n plus 3. And that's important to us because the 4n plus 1 multiples of pi over 2 are going to be our relative maxes. And the 4n plus 3 multiples of pi over 2 are going to be our relative mins. For cosine, the values are very similar because we're stuck with those same 6 values. Square root of 3 over 2, square root of 2 over 2, 1/2, 0, and 1. We don't have any other numbers. So let's see. At 0, cosine is 1. And the next nice value is pi over 3. At pi over 3, cosine is 1/2. Let's see, pi over 6 pi over 3, pi over 2. Those are our first values. At pi over 6, pardon me, at pi over 3, we get 1/2. At pi over 2, cosine is back to 0. And then in the second quadrant, we get those same numbers, but the negatives. So we have 2 pi over 3, 5 pi over 6, and pi. We're skipping the pi over 6s, but I know that 2 pi over 3, the cosine is negative 1/2. At pi, the cosine is negative 1. And we're just going to repeat those values. There's a list of all of the values on page 3 of the notes. And here's a graph with big red dots. So we start at a max. By 2/3 of the way, well, yes, 2/3 of the way across the first quadrant, we're at 1/2, then 0 at all the way at the end of the first quadrant, into the second quadrant, -1, end of the third quadrant, 0, end of the fourth quadrant, back to 1. So for cosine, let's see, at 0, at 2 pi, at 4 pi, 8 pi, -10 pi, every time we have an even multiple of pi, we're going to get a relative max. And every time we get an odd multiple of pi, 1 pi, 3 pi, -1 pi, -11 pi, we're going to have a relative minimum. If we have an odd multiple of pi over 2, so 2n plus 1 times pi over 2 for n in the integers, then we will have an intercept. So those are all of our zeros. Why am I not doing 4n plus 1 and 4n plus 3 here? We just said 2n plus 1 for odd numbers. But let's look at the odd numbers. We've got 1, 3, 5, 7, 9, how about -1, -3? And let's write down the integers. So we have 1, 2, 3, 4, and 5. Oh yeah, okay. And then -1, and -2. Okay, so let's see. If I look at 2n plus 1 for n equal 1, well, 2 times 1 plus 1 is 3. And we had a 0 in the middle that I just left off. 2 times 0 plus 1 is 1. 2 times 1 plus 1 is 3. 2 times 7 plus 1 is 15. So if we add 1 to 2 times the number, we'll always land on an odd number. But every odd number can further be broken down into the 4n plus 1 and the 4n plus 3 categories. So here we don't have to do that. This is where I think this is where we were. Is that right?
I think so.
Okay, super. I want you to notice something about the two graphs. Do you see that basically they have the same shape?
Yeah.
The sine curve is like the cosine curve shifted over by pi over 2. So that's very important for us. The graphs of sine and cosine are the same, except for a horizontal shift of pi over 2 units. But both of them go from a max to an x-intercept to a min to an x-intercept to a max, etc. And those things happen at every quarter of the period. So for example, for cosine, we start at a max. The period is 2 pi. Let's see, where's 2 pi? There it is. There's 2 pi. 1/4 of 2 pi, that's pi over 2. And yeah, okay, I go from a max to an x-intercept plus pi over 2 again. We get down to a min plus pi over 2 again. I get to an x-intercept plus pi over 2 again, and I'm back to a max. And the same thing happens with sine. I started an x-intercept plus pi over 2 gets me to a max plus pi over 2 gets me back to the x-axis plus pi over 2 gets me to a min plus pi over 2 gets me back to the x-axis, and it continues. We talk a lot, or you may have heard often people talking about sinusoidal curves or sinusoidal functions. Only sine and cosine are sinusoidal. Only sine and cosine have this shape, where they're going up and down, up and down, up and down. So every single sinusoidal or oscillation type function in the world can be modeled either using sine or cosine in this general way. We have a number out front. We're going to call that A. Sine of x is the argument. B is the number multiplied by x. C is the number subtracted from b times x. And D is the number added to the whole thing. We're going to use the same notation for sine and cosine. Using our graph here, the distance from the x-intercept to the max or to the min is the amplitude. And the amplitude is always the absolute value of A. The reason we have to use absolute value is that amplitude is always positive. If the number in front of sine or cosine is negative, it just means start in the lower area, but still the amplitude is going to be a positive value. If we're looking at points and we're trying to figure out what the amplitude is, we're going to take the maximum, subtract from that the minimum, take the absolute value of that, so it doesn't matter if we get them in the wrong order, and divide that by 2. So that's another way to find the amplitude. The period of sine or cosine is normally 2 pi. So when we have a number possibly in front of x, we say that the period is 2 pi divided by the absolute value of b. Again, we say absolute value of b because period is a positive thing. So if for some strange roll of the dice, if b happened to be negative, the period still has to be positive. Then we're subtracting c, which is really important. We always have to make sure that the sign, the SIGN in the middle is a minus sign, and that c is whatever comes out of that. C is not going to give us our horizontal shift. Our horizontal shift is going to be, and it's called phi, and some people say phi. Some people say phi, which I spell it the same way. But it's this symbol. It's the Greek letter phi, and you can find it by taking C and dividing it by B. This time, there is no absolute value on either of these. If phi is positive, we're going to shift to the right. If phi is negative, we'll shift to the left. And then this number at the very end, D, is our horizontal, our vertical shift, up or down. So all of this information is the same for both sine and cosine. So let's look at the procedure for graphing the general sine function. So we call this the general sine function. A sine of, remember to say of when you get to parentheses, a sine of bx minus c plus d. So the first thing we want to do is figure out a, b, c, and d. Then we know that the amplitude is the absolute value of a. The period is 2 pi divided by the absolute value of b. B is c divided by b, and d is just going to be itself. The vertical shift is just d. Once we find the period, remember that we said that sine and cosine go from max to x-intercept to min every quarter of their period. We're going to use that right here. We're going to take the period and divide it into 4 parts. And for each part, we'll have the 0th part, first, second, third, and fourth. So we'll have 0 times times p over 4, 1 times p over 4, 2 times p over 4, 3 times p over 4, and 4 times p over 4. To each of these x values, we're going to add phi. Sine starts at 0, so we're going to start at the y value, 0 plus d, and then sine goes up to a, so a plus d. Remember, d is the vertical shift. And then we're back to 0, so 0 plus d is just d. Then we're going down to negative a plus d, and then finally we're back to d. Do you see that that gives us 1, 2, 3, 4, 5 points? And that's why we call this the 5-point summary. Every single sinusoidal graph can be best defined or described using its 5-point summary. Okay, so let's start with f of x equals -4 sine of pi times x. And let's identify a, b, c, and d using this convention. A is the number out front, b is the number next to x, c is the number subtracted from the x term, and d is the number added to the whole thing. Do you see that here a is -4, b is pi, and c and d are 0? It is very important to me that I see this in your homework and on tests, that you list the values. Now, we said that the amplitude was the absolute value of A. So our amplitude is the absolute value of -4, which is 4. The period is 2 pi divided by the absolute value of B. We put absolute value only because both amplitude and period are positive quantities only. So let's see, we've got 2 pi. We said B was pi, so divided by pi. Well, that's weird looking, but we can do that. Okay, the pi's divide out, we're left with 2. And we said that C and D are both 0. That means that B, which is C divided by B, that's going to be 0 and D is 0. So the vertical shift and the horizontal shift are both 0. I didn't quite have a chance before our class started, but I'm making a handout with this information on one page and the cosine information on the reverse page so that you can have that always. You do not need to memorize this. And that's why I tried to make it big. So the next step, now that we have found B, we have found P, we have found amplitude, and we found the vertical shift, the next step is to find 1/4 of the period. So let's see, that we've got the period divided by 4. And we said that the period was 2. So every 1/2 units, we're going to have the zeroth, first, second, third, and fourth. So we'll have 0 times 1/2, 1 times 1/2, 2 times 1/2, 3 times 1/2, and 4 times 1/2. Sine starts at 0, then it goes up to A, back to 0, down to negative A, back to 0. Oh, but wait, we said A was negative. This still works. So here, we can start filling this out. 0 times anything is 0, so our first point is 0, 0. 1 times 1/2 is just 1/2, and we said that A was negative 4. 2 times 1/2 is 1, comma 0. 3 times 1/2 is 3/2, not 1.5. Okay, it is 1.5, but a negative 4 is just 4. So 3/2, comma 4. And then finally, 4 times 1/2 is 2. And you should always get the exact period. So we started at 0, we ended at 2, and we said our period was 2. So check. These 5 points, 1, 2, 3, 4, 5 points, are our 5-point summary. So here's 0, 0, 0.5, negative 4, 1, 0, 3/2, 4, and 2, 0. What this method will give you every single time is all critical points, every important point. It will give you one complete period, and it will give you all critical points or important points in that period. We're going to do one more, and then y'all are going to do a try this. Okay, for the sinusoidal function, f of x equals 3 sine of 2x. Let's see, that's a sine bx minus c plus d. What is a, b, and c? What are a, b, c, and d?
A is 3, B is 2, and then C is 0, D is 0.
Awesome. Was that Sir Ralph?
Yes, ma'am.
How excellent. I wasn't even looking and I thought it was you. Okay, great. Since A and B are positive, it's much simpler to write down that the amplitude is just A, which is 3 in this case, and the period is 2 pi divided by b. So 2 pi divided by 2, which is pi. Since c is 0, phi is 0, and d is 0. So the next thing that we want is to find the period divided by 4. Our period was pi. So we want to divide pi by 4, which is just pi over 4. We'll have the zeroth, first, second, third, and fourth. Amount of pi over 4. So we'll start at the zeroth, 0 times pi over 4. Then the first, 1 times pi over 4, 2 times pi over 4, 3 times pi over 4, and 4 times pi over 4. We're doing sine. I know sine starts at 0, goes up to a, back to 0, down to negative a, back to 0. And did you notice last time that even though we used the word, or I used the word up to a, down to negative a, this rule gave us the correct value for that second point as -4, because we just plugged in a. So let's see, what is 0 times pi over 4?
Zero.
Good. So again, our first point is 0, 0. We said that a was 3, and 1 times pi over 4 is just pi over 4. 2 times pi over 4, that's 2 pi over 4, or pi over 2, back to 0. 3 pi over 4 doesn't reduce, down to -3. 4 pi over 4 is just pi, back to 0. And we said that pi was our period. Oh, good. We started at 0, ended at pi, and that was our period. So that check. And let's see. Are these the same 4 points, 5 points? 0, 0, pi over 4, 3, pi over 2, 0, 3 pi over 4, -3, and pi 0. And there they are. I want y'all to do try this number 1, but I want to show you one thing. What is B here? If I use A sine bx minus c plus d, what is B?
1/2.
Good. B is equal to 1/2. We said that the period was 2 pi divided by B. Well, that's messy. 2 pi divided by 1/2. Is division the same thing as multiplication by the reciprocal?
I think so, yes.
Yes. So division equals multiplication by the reciprocal. I can't spell today, reciprocal. And what is the reciprocal of 1/2?
Two over one.
Good. So 2 pi times 2, which is just 4 pi, is the same thing as 2 pi divided by 1/2. So division is the same thing as multiplication by the reciprocal. I'll write that up neatly, but I want y'all to work on this. And I'm going to be here, but I'm going to turn my camera off so that I can hear y'all working. Sorry.
Hey guys,
Hey, what's up?
y'all doing okay?
Yeah, I'm doing okay.
We can't see the question. Where's the question at?
I think it's just to try this
Oh, there we go.
right there.
There we go. Yeah. All right. All right. How's y'all's spring break?
Pretty good. Yeah.
Good. Oh, by the way, it's still recording.
So
This is good
start
because
off.
I had forgotten to resume the recording.
We'll check mine.
Yeah, sure. I could list my the points, the 5 points.
Yeah.
Yeah. So the first point is 0, 0. Second point is pi, and negative 1/3. 2 pi 0, 3 pi 1/3, and 4 pi 0.
All right, cool.
Okay. So I know you are all chomping at the bit to see what happens when C isn't 0. So here we have f of x is equal to 2 sine 3x minus pi over 4. So let's see, A, B, C, and of course D is 0. But it's really, really important to remember that the form of this equation is that C has a negative sign in front of it. So A is
2
good, and B and C.
pi over
What?
4 or negative pi over 4?
Good, positive pi over 4. So as long as there's a negative sign, C will be positive. If there was a positive sign, we would think of that plus sign as negative, negative. So that C would be negative. Okay, so we've got the amplitude. A is positive, so it's just going to be 2. We know that the period is 2 pi over B, and B is also positive. And C gives us B. So we have pi over 4. Division is the same thing as multiplication by the reciprocal. So this is equal to pi over 4 times 1/3. So division equals multiplication by the reciprocal. So here, phi is going to be pi over 12. Whenever phi is positive, we're shifting to the right. If phi were negative, we would shift to the left. But we've got to remember that the sign in the middle has to start out being a negative for all of that to be correct. And we have one other thing. We need to find the period, which was 2 pi divided by 3. Well, we can't do anything with that. So the period is 2 pi over 3. And I'm going to get another piece of paper. Here we go. We have that period equals 2 pi over 3. And that means that the period divided by 4, that's 2 pi over 3. Division by 4 is the same thing as multiplication by 1/4. Why is that helpful?
By multiplying?
Why is it helpful to be able to say division by 4 is the same thing as multiplication by 1/4?
So it removes an extra step.
It removes a step. When this number in the denominator is a fraction, it removes a big extra step. But it's also, it isn't just removing a step, it's a higher level of thinking. Connecting those two things, like we're always used to saying subtraction is just adding the opposite. But we end up not extending that idea to division and multiplication. Okay, so we've got 2 pi over 3 times 1/4. Can I reduce before I multiply?
Yeah.
Good. And so we end up with pi over 6. And we could multiply and then reduce. If we multiplied first, we would get 2 pi over 12. And then reducing that, we get pi over 6. To get the same thing. So we're going to look at every pi over 6 of a unit. So we're going to start out with 0 times pi over 6, 1 times pi over 6, 2 times pi over 6, 3 times pi over 6, and 4 times pi over 6. But this time, we're going to add phi every step. We said that phi was pi over 12. So plus pi over 12, we start at 0. Plus pi over 12, we go up to a. Plus pi over 12, back to 0. Plus pi over 12, down to negative a. Plus pi over 12, back to 0. And now we can fill in some values. The first one starts out nice because 0 times pi over 6 is 0. 0 plus pi over 12 is pi over 12. So we're going to start this at pi over 12 comma 0. Next, we've got 1 times pi over 6. So that's pi over 6 plus pi over 12. What can we multiply 6 by to get 12?
2.
Good. And we said that A was 2. So let's see, we've got 2 pi over 12 plus pi over 12. That's 3 pi over 12. And can we reduce that?
Yes.
Just say, I'm telling my brother I'm in class because he keeps texting me. Okay. And so we get pi over 4 for the first. So this is going to be pi over 4 comma 2. This next point, I could reduce the 2 and the 6, but if I don't, then I can use the same algorithm that I used in the previous step. So I'm not going to reduce, but I do want extra paper. So I've got 2 pi over 6 plus pi over 12. And I'm going to multiply 2 pi over 6 by 2 over 2. That gives me 4 pi over 12 plus pi over 12, which is 5 pi over 12. So the third point is going to be 5 pi over 12 comma 0. And then we've got two more. We've got 3 times pi over 6 plus pi over 12. So let's see, that's 3 pi over 6 plus pi over 12. And I can multiply 3 pi over 6 by 2 over 2. That gives us 6 pi over 12 plus pi over 12. And that is 7 pi over 12. So we get 7 pi over 12 comma negative 2. And then one more time, we've got 4 times pi over 6 plus pi over 12. And that's 4 pi over 6 times 2 over 2 plus pi over 12, which is 8 pi over 12 plus pi over 12. That's 9 pi over 12. And one more time, we can reduce this. We can divide them both by 3. And we get that the final value is 3 pi over 4. And remember, we said that we want one complete one complete period to be the actual period. So let's see, before we reduced it, we had 9 pi over 12 for 3 pi over 4. We have 9 pi over 12 minus pi over 12. That's 8 pi over 12. We can divide these both by 4. We get 2 pi over 3. Yay. And you can see why we started out our class by reviewing fractions. Because it's just really beautiful if they make sense and really frustrating if they don't. So that's how we end up with, our critical values. And then we just plot them. For cosine, oops. For graphing cosine, we're going to start out the same way. We're going to identify A, B, C, and D. We're going to find the period divided by 4. And with cosine, we always start high. So we start at A. So our first value, the input is the same, 0 times P over 4 plus B, but the output is A plus D, then 0 plus D, negative A plus D, 0 plus D, and A plus D to get the 5-point summary. What does extremum mean?
Uh,
The max.
one of, if not the highest or lowest point.
That's right. Exactly right. So here we don't know whether we're going up or down to begin, because that depends upon the SIGN of A. If A is negative, we'll start low. If A is positive, we'll start high. But so that we can describe this in general, we just say that that has to be an extremum and then an intercept in the middle. Okay. So we've got f of x is equal to the cosine of x minus pi over 6 plus 1. What are A, B, C, and D?
A is 0.
Is it 0?
It should be 1.
It's 1.
1, yeah. Yeah, good.
B is also 1. C is pi over 6. And D is 1.
Excellent. Excellent. So let's see. We know that the amplitude is just 1 and that the period is just 2 pi. We also need phi. Phi is C over B. Well, what is pi over 6 divided by 1? What is anything multiplied or divided? Yes, good. Okay, and we need the period divided by 4. Well, that's 2 pi divided by 4, which is?
Pi over 2.
Good. So we're going to have 0 times pi over 2 plus pi over 6 comma A. 1 times pi over 2 plus pi over 6 comma 0. Oh, plus D. 2 times pi over 2 plus pi over 6 comma negative A plus D. 3 times pi over 2 plus pi over 6, 0 plus D, and finally 4 times pi over 2 plus pi over 6 comma A plus D. Just 1 second, guys. Okay. 0 times pi over 2 is 0. 0 plus pi over 6 is just pi over 6. We said that A was 1 and that D was 1, so we get comma 2. Here we go. We get some more fun working with fractions. We have pi over 2 plus pi over 6. That's 3 pi over 6 plus pi over 6, which is 4 pi over 6, which is, we can divide out by 2, and we're left with 2 pi over 3. 0 plus 1 is 1. And now we have 2 pi over 2, and I'm going to again multiply by 3 over 3 because I'm adding pi over 6. So that gives us 6 pi over 6 plus pi over 6. So 7 pi over 6. And then negative 1 plus 1 is 0. Now we have 3 pi over 2 times 3 over 3 plus pi over 6. That's 9 pi over 6 plus 1 more pi over 6. That gives us 10 pi over 6. And that reduces, we can divide by 2. We get 5 pi over 3. And 0 plus 1 is 1. And finally, we have 4 pi over 2. We're going to multiply that by 3 over 3 and add pi over 6. So that gives us 12 pi over 6 plus 1 more pi over 6. That's 13 pi over 6. And 1 plus 1 is 2. And you can see this time it's easier to see that 13 pi over 6 minus pi over 6 does definitely give us a period of 2 pi, because it gives us 12 pi over 6, which is 2 pi. And then there are the 5 points. You can see this time that the intercepts are actually the center of the axis of oscillation, which we'll talk about more after a break, because I'm getting several people texting me, so I need to see what's going on. Any questions before we take a short break?
No questions here.
Okay,
No
swell.
questions.
Thank you. Okay, thanks, y'all. I just found out that our president, Dr. Nadine, is stepping up to something in district, and Dr. Solis is back as our interim president. So kind of crazy. I do want to make every single one of you aware that I expect that you will be doing this fraction, addition, and subtraction, and all of that. So we are going to be doing this. All right. Here is a try this for y'all. And the the 5 points for cosine are here on the left.